Problem 2 says the function y equals g of x is graphed below. We're told it is continuous on the closed interval from 0 to 4 and differentiable on the open interval from 0 to 4. And we can clearly look at it at the visual of the graph and see that this is a function. So right off the bat from this first sentence, the mean value theorem applies here. So we're going to be able to use it. It says find all values of c satisfying the conclusion of the mean value theorem for this function. This says assume the grid lines are 1 unit apart. So we're just going to estimate, because we're doing things with graphs, we don't actually have the formula to do the exact math values. So if we're testing the mean value theorem from 0 to 4, the first thing I want to do is I want to find the secant slope. Because we do the secant slope first and then use that to predict the location of the same tangent slope. So the secant slope part of the formula is f of b minus f of a over b minus a. We're checking the interval from 0 to 4. So this is f of 4 minus f of 0 over 4 minus 0. So now I can look at my graph, and we're assuming that this is the origin. So if I go over 1, 2, 3, 4, I go up 1, 2, 3, 4. So f of 4 is 4. F of 0 is up at 1. And so I get a secant slope of 3/4. So because the conditions of the mean value theorem were satisfied, there should be at least one location on this graph where I'm going to get that same slope. So the first thing I'm going to do is I'm going to actually now draw my secant line, and I'm going to draw it in the same color red. So there's f of 0, right? There's f4. So there's my secant line. So there's m equals 3/4. Now I'm going to see how many places, there should be at least one because the conditions were met. Where can I find a secant slope or a tangent slope that equals this? So I'm going to line my ruler up with my line, and without rotating it, I'm just going to slide it until I can find a point where it's only touching it in one point. So it's a little bit hard for me to see underneath, so I'm just going to flip this guy around and do it this way. So now if I slide this back, I can see that right about there, the ruler's touching it in one spot. So I'm going to draw my line, and hopefully it looks parallel. So that's good. So there's one value of C. Now I'm going to go the other direction just to make sure that there's not a second location, and it looks like right there, there's another spot on the graph where I'm going to get that same tangent slope. And so we have a second location. So I'm going to call this C1 and this C2. So they just want us to estimate the x value. C represents the x-axis. So this looks like we're almost halfway between 1 and 2. So I'm going to say it's a little bit less than halfway. So I'm going to guess it's about, I don't know, let's say 1.4. And this looks like it's pretty much halfway in between 3 and 4. So we'll just call that guy 3.5. So best we could do is approximate, but you can see that all three of these lines are parallel. And so this line represents f prime of C1, and this prime line represents f prime of C2. So if I were to plug the values of C1 and C2 into the derivative, if I had the function, it should come out to be about 3/4.